Alright guys, so today we're going to talk about water and its significance. Basically, its significance as different states. We're going to give a little bit more background and an overview of the unit as a whole, and we're also going to talk about a model for water. Okay, so what's the point? Basically, by the end you should be able to describe the structure of water. Now, later we'll compare it to other molecules that are similar, and we're going to outline its significance on Earth. Okay, so first off, the molecule of water, it's a polar covalent molecule. So these are all of one oxygen, two hydrogens. Now, that is a separate statement to that. Okay, so is a polar, covalent molecule of one oxygen and two hydrogens. And we can see here are several different ways to represent it. Now, these are so if we're down here, this is where we draw it with an electron shell. Over here we have what we call the space-filling models, and it basically shows you your distribution of charges. Over here we've got the stick and ball model, and here we have everyone's favourite, the Lewis dot structure diagram. Now, the Lewis dot structure diagram is cool. The way we would draw this is that would be a cross, and that would be a cross to show that those electrons are coming from the hydrogen atom, and the other six all come from the oxygen. And this one here just shows the bonds. Alright, so let's go. Now let's have a quick look here. Basically, this is a great table. If you get this down, gold. If you don't, you don't. That's cool, but this is a good summary of essentially everything about water that we're going to go through. We'll go through everything in more detail, but so be it. And these are the significances. Now, it absorbs infrared radiation. That means it absorbs heat, and therefore it relates to greenhouse warming. Okay, it's found in planetary atmospheres. It's abundant throughout the solar system, includes the outer solar system, and essentially water came to Earth in comets of water, not comets of hydrogen, comets of oxygen hitting together, boom. That would be crazy, but it does come as comets with water. Alright, so let's get to this. So if you take a chance, go for it. It's a temperature moderator, which is really cool. And this comes down to the fact where it absorbs, where are we? Where's my mouse? It absorbs infrared radiation. So it's a temperature moderator. So this is a terrestrial environment, particularly probably a desert by the look of it, given it goes up to 30 down to 15. That's a big change. And if you look at what the ocean temperature is, it's a much smoother change as the day goes along. So because it absorbs infrared radiation, it can moderate temperature differentials. In other words, the differences between. So your extremes, it's called dampening. They sort of come into the middle, so it's not as big an effect. This reduces the fluctuations. So for a fish, now fish, remember they're essentially a cold-blooded animal, so the water stays more or less consistently temperature for them. Now, it moderates the temperature fluctuations on a coastal environment where it's much more humid. If it's a more humid, starting to go a bit Mario there, if it's more humid in an area, then you're going to have smaller temperature differentials even in the air. Okay, so this is one of the reasons that we have more vegetation and reliable vegetation on the coast than we do inland. It's harder for stuff to grow because the temperature more extremes, and that can be quite bad for the animals. I mean, if our core temperature changes by, I think it's about a degree, we're dead. So stable temperature is actually really vital, particularly at the start of life. Water in cells. So basically it's the medium for everything, and we can see that it has physical uses here and chemical uses, and we'll get into that in a minute. So basically though, our cells are roughly 70% by water, and you in particular, you're about 67% water, which is pretty cool. And as we said before, metabolism are the total chemical reactions for life. Now, what does it do for you personally? You need it for the hormones and the neurotransmitters to work. Saliva. Mucosal membranes, like these are one of the barriers to infection, they need to be moist. Helps regulate your body temperature, allows your body cells to grow, reproduce, and survive. Shock absorbance for the brain. If you drop a brain in a protective case, like a helmet, it'll still break if it's not surrounded by water to absorb that shock. Move stuff around the body, move stuff out of the body, etc. So basically, that's what we're getting at here, and this is a really important table. Again, it comes from your textbook, table 11.3, if you'd rather copy it from there. So the physical stuff, it's a transport medium, it's a solvent, and it's required for reproduction. You know, basically all of our reproductive cells, which have to go from one body into the other, they need a watery medium to move around in. But just as interesting is over here. It's produced by respiration, so when we break sugar down, we get water as a product. Basically, respiration of sugar is burning. You're combusting it, but it's so you're combusting it to produce carbon dioxide and water. We can use it. We need it for photosynthesis, so it actually helps make up that sugar, and that's why it's a product here. And if you have a look, this swaps over with this. So photosynthesis is the opposite of combustion, and we use it to break it down dietary fat. It shapes the landscape massively so. So flowing water, whether it's a moving solid or liquid, that can cause erosion of rocks. It wears them away, erosion of rocks through it. That's an insane sentence. Ignore that one. But a really good example is frost wedging. Actually, we call it ice wedging. And yes, got that right. We call it ice wedging. And basically, the water melts in, so it pours in, and then it freezes. And because it expands, which is odd, by the way, it causes the rock to break apart, and eventually that breaks the rock. The solutes in the water, it's solute, it's not solutes, or it's solutes. The solutes in the water, they can chemically weather it, so you've got acids, bases, they can break down rocks, and some minerals, rocks, like limestone, dissolve in water, which means they will break down. Okay, water is a resource. This is important. Potable means drinkable, okay, so boom, that means you can drink it. 90% of it comes from groundwater. Most people think our drinking water comes from rainwater, and it does originally, but it's not from surface lakes, it's from groundwater. Now, all this water eventually moves back to the ocean, and only 3% of water on Earth is fresh. 77% of that, or thereabouts depending on the numbers, I think it's closer to 70, is locked up in glaciers. We just can't get at it any other way. That's where it lives. So, yes, that's water as a resource, that's water, its usefulness, and also the model of it. And we'll get more into that later on. All right.